Hey guys, welcome to our Docker certification series. In this series, we will go ahead and talk about or take a look at in detail the Docker certification as an exam. This series is just not merely going to focus on the certification part, but it will also make sure that you will have a good hands-on. Because Docker certification is not just about picking multiple choice questions or anything. It is a really hands-on exam. Just like some of the other certification, if you have done any Red Hat examination like RHC-SA or RHCE, it kind of follows pretty much the same thing where you have some questions followed by some hand-on exercise. So in this series, we'll go ahead and explore Docker certification or Docker in pretty great detail. This series will have a balance of both some theoretical concept as well as hands-on. If I have to really quantify, we would be spending close to 30% of our time going through some of the theoretical concept. But at the same time, we will be spending close to 65% to 70% of our time, or 70% will be on the hands-on. Because the Docker is really all about hands-on. Even your objective is not to really go for the Docker certification. You will still find this training to be very useful in your day-to-day life, or if you're just trying to learn to the Docker, or if you are new that just started working with the Docker. So with the Docker certification, there are some of these topics as we progress throughout the series. We will go ahead and explore some of these things in pretty great length and pretty great detail. So in this very introductory session of the Docker, we'll go ahead and explore some of the terminologies before we really deep dive into the world of Docker. So I will be making use of a lot of official documentation, and there are certain good blogs out there that describe certain features in pretty good detail. So we will be making use of those features or those documentation or those blogs throughout this series. So without any further delay, let's understand some of the basic thing before we learn a Docker in more detail. So I kind of find this particular blog to be pretty good. So credit goes to these guys. So let's understand what are containers and what are VMs. Because we are trying to work with the Docker, which a lot of people just also calls a container nowadays. But there used to be a technology by name containers itself. So before we deep dive again into Docker, let's understand some of these things. Again, you can go ahead and read some of these things pretty great detail onto their website, but I'll go ahead and give you a brief information about the Dockers and the VMs. So if you take a look at here, the containers and VMs are pretty much similar in their goals. And the goal is to really isolate an application and its dependencies into a self-contained unit. And that unit you can primarily run anywhere. So let's take an example of a VM. So you could go ahead and deploy a VM on one ESXi host, and later on you can decide to migrate or take that VM to a different ESXi host if you are using VMware as your virtualization technology. At the same time, you can go ahead and do that. So the main thing, the container and VM really removes the need for physical hardware. That means allowing for more efficient use of computing resources. Because before really the VM and the container came in, we used to deploy the whole application on a standard box. And moving to the VM and container kind of helped us away, taking away that requirement. Now on a single box, you can go ahead and deploy multiple VMs. If both are doing the same thing, then what exactly is the difference? As the author of this blog clearly says, okay, hey, it's in their architectural approach, the way they have designed some of the things. So let's take a look at what is virtual machine. A virtual machine is essentially an emulation. So take a look at what it says, an emulation of a real computer that executes program like a real computer. And moreover, the VMs run on top of a physical machine using a hypervisor. So pay attention to the word hypervisor. So if you want to run a VM, you would need a physical machine. On top of that physical machine, it could have its own operating system, and on top of that operating system, it can have a hypervisor layer. If you go a little back, like when Microsoft came out, you would have to install the Windows as operating system, and on top of that, you had to install the Azure layer before you can go ahead and start creating a VM. On the other hand, if you take a look at example of a VMware, you could take a physical machine, and on top of that physical machine, you can go ahead and install your ESXi as an operating system, which in fact also acts as a hypervisor. And on top of that hypervisor, you can go ahead and start creating your VMs. So the main thing, there are a couple things that were involved here. So sometimes the VMs in the VM world are also called as guest machine. That means the guest machine contain both the application as well as the operating system. That means, let's say, if you want to run Linux on a VM, you can go ahead and create a VM that will have its own full operating system as well as the applications. So if you take a look at this particular picture, you will have a server, which is nothing but your hardware. On top of that, you will have host operating system, going back to an example of our Windows. And on top of that, you will have a hypervisor, like the Azure layer. And once that is done, you can go ahead and start creating your VMs. The VM will have its own guest operating system, its own binaries and libraries. And on top of that, it will have the application that you plan to install. On the other hand, if we take a look or talk about the container, again, just unlike the VM, which provides a hardware virtualization. On the other hand, the container provides something called as an operating system level virtualization. And how do they do that? With the help of a concept, something called user space. So they go ahead and abstract the user space. And again, we'll go ahead and talk about these things, some of the things in pretty greater detail. So if I have to highlight, this is the one line I definitely want to highlight. That clearly says the one big difference between container and VM is that container share the host system's kernel. So that is the main thing with other container. So that means they are kind of making use of the host kernel and to do that. So if you take a look at this picture, you will have again have a server, just like in the case of a VM. You again will have an host operating system. And now you will have something as your Docker engine, which is they will go ahead and share. This is an example of Docker engine. So in this layer, when you bring up the container, all of these containers are sharing the kernel resources. And how are they doing that exactly? So that's where this Docker really came into the picture. So Docker is an open source project based on Linux container. So the whole idea initially, it was derived or founded or came up into the concept was because of the Linux container. And because it came through Linux container, it used some of those technologies that made container to be a viable option that time. And those technologies or the features are based off the Linux kernel, and those features are called your namespace and control groups. Without the namespace and control group, it's really impossible to create a container. And that's where these two things are the one that are really creating the magic. So this namespace and control group create container on top of an operating system. So before we really deep dive into Docker, we would have to really understand what is namespace and what is control group. Like as I said, without the namespace and control group, it's not possible for us to go ahead and create any type of container, no matter it's a Linux container or a Docker container. So let's take a little bit in detail more what is namespace and what is control groups. So let's quickly talk about the namespaces. So the Linux namespaces. So Linux namespaces is basically some of the fundamental technologies that are kind of behind, as it clearly says, today's container implementation. At a very high level, main thing the namespace allows, they allow for the isolation of global system resources. Something to keep in mind. So you have the global system resources. What are the global system resources? And we'll go ahead and take a look at it. So with the help of namespace, we can go ahead and isolate them between independent processes. As the author of this blog clearly says, okay, hey, for take an example, the PID namespace isolates the process ID number space. And if you want to take a further look example, let's take a look. The level of isolation is clearly useful in the world of containers, because when you are dealing with container, we definitely need that isolation, because that's the whole concept behind the security and other things. If we cannot isolate, we will run into a problem, and that's what the author clearly able to explain here. Without namespace, a process, let's say a process is running container A, could, for example, unmount an important file system in container B, or change the host name of container C, or remove a network interface from container D. By namespacing these resources, the process in container A isn't even aware that the process in container B, C, and D even exists. So that is the beauty, and that beauty or this functionality is really brought in by this namespace. There are multiple namespace, but before that, let's understand one more line. Note, the namespace do not restrict access to physical resources. So we're not talking about the physical resources here. When we say physical resources, CPU, memory, and disk, that whole restriction is driven or taken care by another feature called a cgroup. And we'll go ahead and take a look at some of these things in more detail. So there are 7 different type of namespaces available in your Linux kernel. We have one is mount, second is UTC, IPC, PID, network, user, and cgroup. Again, I would highly encourage you to spend some time and reading through them in more greater detail. Now let's quickly understand what is cgroup, because we just learned, okay, hey, the namespace is not really restricting access to physical resources. But when you're working with container or the VMworld or anything, or Docker per se, we definitely want to restrict some resources because we don't want a single container to be consuming all of our CPU memory and disk, and we don't want to starve our rest of the container. So we would need a mechanism in place that can restrict these things. And that's where the cgroups really comes handy. So let's talk about the cgroup. So the author of this blog that we are referring here, the control group, which is short for cgroup, is a Linux kernel feature that we know. And the whole idea behind which limits, isolates, and measure resource usage of a group of process. Resource quotas for memory, CPU, network, and IO can be set. So with the help of cgroup, we can go ahead and govern the quota onto some of these things. We know that Linux by default is pretty good and excellent in handling and sharing available resources between processes. But sometimes we want a better control. And because of this better control, we go ahead and make use of another feature, which is called as your cgroup. And both the namespace and the cgroup are the one that really help make this Docker as a kind of technology where it stands as of today. So hopefully you will have some idea. Now with that, let's move into the Docker and try to understand some of the fundamentals before we can really get onto more deep dive. So Docker overview, pretty much as simple. Docker is an open platform for developing, shipping, and running applications. It's all about applications. So that is something, we need to pay attention. It's really about application. Docker doesn't care what kind of infra you have. It doesn't force you that you need certain kind of infra. So that means you can go ahead and start developing an application on your local laptop, and later on you can go ahead and decide to deploy that application on a production or any kind of a cloud provider out there. So that is the beauty. That's why the second line clearly says Docker enables you to separate your application from your infrastructure so you can deliver software quickly. There are other great details about the Docker that you can go ahead and make use of. So Docker provides ability to package and run an application in loosely isolated environment called a container. So that is another beauty. It's loosely isolated. This isolation and security allow you to run many containers simultaneously. Now you know how that isolation happens, and the security is all thanks to the namespace and cgroup. Without that, this thing is not possible. On the other hand, the containers are lightweight because they do not need the extra layer of hypervisor. And the reason why they don't need, because they share the same host kernel. And that's one of the reasons they are very lightweight. And because they are very lightweight, you can go ahead and spin or bring up multiple or a lot more number of container on a host versus the number of VMs. Again, you can go ahead and read some of these things in pretty great details on the docs.docker.com. So let's learn a few more fundamentals or the basic things before we move further. So let's take a look at this whole picture of the diagram here. This picture at the center here clearly shows there is a server, which is also depicted as a Docker daemon. So it clearly says this is the heart, this is the core of the whole Docker. This is the server that does all the heavy lifting, all the major work for you. And to communicate or to interact with the Docker daemon, we have a REST API as the layer. This REST API layer sits between the server and the Docker client CLI. So using the Docker CLI client, we will be interacting with the Docker server using or with the help of this REST API. At the same time, this Docker will be managing or will be able to manage the networks, data volumes, images, and containers. So with that, let's explore some of these things a little bit in more greater detail. A Docker engine. So sometimes the Docker server or Docker daemon is also called as Docker engine, which is simply a client server application. So that means there is a client and there is a server. As you can see in the picture, we have a client, which is the Docker CLI, and we have a Docker daemon, which is your server. And here it clearly says a server, which is a type of long-running program called a daemon process. Sometimes it's called a Docker D command also. It means it is Docker service. The REST API, which specifies the interface program that can be used to talk to the daemon. That means talking to the server. And we also have a CLI, the command line interface client, which is called Docker command. Using that also, we can also interact with to the server here. Now let's take a look at some of these things a little bit in greater detail. So let's quickly going over to the Docker architecture. So in this diagram, you can see in the middle, we have the Docker host. The Docker host is nothing but a machine running your Docker server, which is also depicted with the help of your Docker daemon. On the left-hand side, we have a client machine where we have a Docker client installed, and Docker client is communicating with the Docker host, and it's actually communicating to the Docker daemon. And the Docker client, whenever it sends a command, those commands are being sent to the Docker daemon, and Docker daemon does all the heavy uplifting of creating the containers or managing the whole life cycle of your containers, as well as interacting with the images, as well as pulling or uploading the images to the registry. And we'll go ahead and, again, talk about these things a little bit more greater in the detail as we move further. So let's take a look at what is the Docker daemon. We know the Docker daemon is the server process. So the Docker daemon listens for the Docker API request and manages Docker objects such as images, container, network, and volume. A daemon can also communicate with other daemons to manage Docker services. So the Docker daemon or the Docker D is nothing but a Docker engine or the Docker server. We have something called Docker client. The Docker client is the primary way that many Docker users interact with the Docker, and we will be spending quite a bit of time with the Docker client. There's something called Docker registry. So Docker registry is a place where it will go ahead and store images. So when you install a Docker by default on a machine, it points to a registry by name Docker Hub. So you can go to the hub.docker.com to take a look at it. So this is a public registry where a lot of vendors have uploaded their official images. So let's say you want to create a container based on Ubuntu or CentOS. You can go ahead and download those official images from this public registry. You can also go ahead and start hosting your own images also. As well as you can go ahead and create your own private registry. And Docker has an application for that. So you can go ahead and make use of something called Docker Data Center. That includes a DTR, which is Docker Trusted Registry. You can go ahead and make use of that to start hosting your own registry also. So during this diagram, we took a look at there is something called container, images, and this diagram we saw there were a couple more things. There is network, volumes, image. All of these are called objects. So these are called Docker objects. When you use Docker, you are creating and using images, containers, network, volume, plugins, and other objects. So that's what it's really going to talk about. So before we kind of jump further into detail, I want to talk about a couple more things. So the version or the edition of the Docker that we will be using in this training is called Docker Engine for Community Edition. There are actually 3 variations of the Docker editions are out there or Docker engines are out there. Number 1 is Docker Engine for Community, which is free. You can go ahead and download and start making use of that one. There is another edition which is called Docker Engine for Enterprise. And we have third one which is called Docker Enterprise. So all of these at the core, they are pretty much same, but obviously Enterprise will have support and few more bits and pieces. For our training, we will be spending quite a bit of time, or we will be just doing majority of the things on the Docker Engine Community Edition. Just like with any other application, Docker also has some drawbacks or some limitation. So one of the limitation that comes into the picture when you are working with the Docker, we just learned they share a host kernel. So that means we cannot have Windows and Linux container on the same host. Because let's say if your host OS is running Linux, so it will be very difficult for a Windows container and vice versa. There's another challenge, I won't say the drawback, but this is a particular challenge. When you are working with container, very soon you will run into large number of containers, and managing that large number of containers becomes very challenging for every day to day. And especially when you're doing any clustering, you will have a lot more number of containers. So to do some of that thing, we can go ahead and start making use of something called the orchestrator. I'm sure you must have heard about the Kubernetes, which is from Google. You can go ahead and make use of the Kubernetes to start managing your Docker containers. There is another program from Apache Foundation called Apache Mesos. Or you can go ahead and start making use of the Docker Swarm also. So these are some of the things that we need to keep in mind before we really deep dive. And again, this is just the part one into the series. Further into the series, we will be exploring some of these things in greater detail. But at the same time, we will be doing lots of hands-on. As I mentioned earlier, it's going to be a lot of hands-on versus the theoretical part. And for theory, I will try to stick it as close possible to the official documentation, because I feel the official documentation is the best place to get any kind of relevant data, and especially when you are working with a certification. Thank you. I will see you in the next episode.